select our projects. One of the key considerations here is choosing between performance and features. Non-relational databases like MongoDB are designed to run anywhere, offering great flexibility. When working with these databases, a fundamental step is generating or creating a key. Think of keys as unique identifiers that help us access specific data quickly. We then use these keys alongside their associated values to store and retrieve information efficiently. Implementing collections is also crucial. Collections are essentially groups of documents, similar to tables in relational databases, but more flexible. They allow us to organize data logically without rigid schemas. Overall, this approach emphasizes performance and scalability, which are often priorities in modern, dynamic applications. It's about making smart choices based on what your project needs most, speed or features, and understanding how structure supports that. Let's take a closer look at this slide. Here, we're emphasizing the importance of understanding the core concepts thoroughly, but in a way that's conversational and approachable. It's crucial to highlight the most important ideas as they form the foundation of what we're discussing today. By connecting these points to the overall theme, we can see how each element fits into the bigger picture, helping us grasp not just the details but the overarching message. This approach ensures that the information is engaging and memorable, making it easier to apply what we've learned in real-world scenarios. MongoDB is a type of document database, which means it stores data in a flexible, JSON-like format called BSON. Now, BSON stands for binary JSON, and it's just a way to encode JSON data efficiently for storage and retrieval. In MongoDB, each individual piece of data is called a document. Think of a document as a data structure made up of key-value pairs, kind of like a mini, structured object. This structure makes it easy to organize and access related data in a way that's very intuitive, especially for developers familiar with JSON objects. One of the key advantages of MongoDB is its flexibility. Since it's a document database, it can be installed right on your local machine or hosted in the cloud, giving you options based on your needs. Whether you're working on a small project or a large-scale application, MongoDB can adapt to different environments seamlessly. Throughout this presentation, we're exploring different types of databases and understanding how this document-oriented approach fits into the bigger picture of modern data management. It's all about choosing the right tool for efficient, scalable, and flexible data storage. All right, let's talk about what a document looks like in MongoDB. In this database, each record is called a document. Unlike traditional tables, these documents can hold a variety of data types in their fields, including numbers, strings, booleans, arrays, and even nested documents. This flexibility makes MongoDB very powerful for handling complex, unstructured data. Now, to give you a clearer picture, here's an example of a document. You can see it has a title, body, category, likes, tags, and a date. The tags field is an array, which allows us to store multiple tags for a single document. Also, notice the date field, which uses a special date object to store date and time information. Understanding these documents is key because they form the core of how data is stored and retrieved in MongoDB. They're flexible, rich, and adaptable, making MongoDB a great choice for many modern applications. Let's take a closer look at SQL versus document databases. SQL databases are what we call relational databases. They store related data across separate tables, which means when you need to retrieve data, you often have to query multiple tables and join the data together. This process is very structured and works well for many traditional applications. On the other hand, MongoDB is a type of document database, which is often referred to as a non-relational database. Now, I want to clarify that this doesn't mean relational data can't be stored in document databases. It simply means that the way the data is stored is different. Instead of using tables, data is stored in flexible, self-contained documents. This approach has a big advantage. It keeps all related information together in one place, which makes reading data much faster and more efficient. Instead of juggling multiple tables, You just work with one document that contains all the relevant data. And in MongoDB, instead of tables, these collections are used to organize your documents. So, understanding the differences between these two database types helps us choose the right tool for our specific needs, especially as we look at how to optimize data storage and retrieval in different scenarios. Let's take a closer look at how MongoDB environments work. Essentially, they provide a server where you can create and manage databases using MongoDB. Think of it as a dedicated space for storing your data efficiently. Now, MongoDB stores data in a very flexible way, using records that are organized into collections and documents. Imagine collections as folders that hold related documents, which are individual units of data. These documents are made up of field and value pairs, similar to key-value pairs in JSON format. This structure makes it easy to store complex data in a way that's both human-readable and machine-friendly. And remember, these documents are the basic units of data in MongoDB. They're what you work with most often when you're adding, updating, or retrieving information. So, in essence, MongoDB works by providing a structured yet flexible environment where data is stored as documents within collections, making it highly adaptable to different types of applications and data models. Now, let's look at how these documents are structured. They're quite similar to JavaScript object notation, or JSON, which you might be familiar with. But in this case, we're dealing with a variant called binary JSON, or BSON. The key advantage of using BSON is that it can handle more data types than standard JSON. This flexibility makes it especially useful when working with complex data. If you think of a relational database, the fields in these documents are like columns. Each field represents a specific piece of data, and having more data types means we can store a richer variety of information within each document. This is particularly important in database systems where efficiency and the ability to handle diverse data are crucial. So, in summary, BSON builds on the familiar JSON format, but enhances it by supporting a wider array of data types, making it a powerful tool for managing complex data structures. So, how does MongoDB actually work? Well, the values it stores can be quite diverse. They can include not just simple data types like numbers or strings, but also other documents, arrays, and even arrays of documents. This flexibility is one of the reasons it's so powerful, as highlighted in the MongoDB user manual. Each document in MongoDB has a primary key, which acts as a unique identifier, kind of like a fingerprint for that piece of data. And remember, the structure of a document isn't set in stone. You can easily add or remove fields as your data needs evolve. This makes MongoDB very adaptable for changing data models. Now, on the architecture side, MongoDB uses a single master setup for data consistency. That means one primary database handles all the writes and updates. But to keep things reliable, there are secondary databases that hold copies of this primary database. These secondary copies automatically replicate any operations happening on the primary, which ensures data stays synchronized. This automatic replication isn't just for keeping data consistent. It also provides automatic failover. So, if the primary database ever goes down, the system can switch to a secondary database seamlessly, minimizing downtime and maintaining data integrity. Overall, this architecture and flexible data model make MongoDB a robust choice for handling complex, evolving datasets in a reliable and scalable way. All right, let's take a closer look at this slide. Here, we're focusing on some key points that are really central to understanding the bigger picture. First, I want to emphasize how important it is to thoroughly grasp each of these concepts, because they all connect back to our overall theme. As we go through, I'll highlight what I think are the most critical ideas. These are the ones that really drive the message home. Remember, this isn't just about isolated facts, it's about seeing how everything fits together. So, as I explain, keep in mind how these points relate to the broader context we've been discussing. This will help us build a clearer, more complete picture of the topic. MongoDB was created by Dwight Merriman and Elliot Horowitz, who faced some significant challenges with traditional relational databases while developing web applications at DoubleClick, which is now part of Google. They realized that the existing systems weren't scaling well or handling large amounts of data efficiently. The name MongoDB actually comes from the word humongous, symbolizing its ability to support very large data sets. It's a fitting name because MongoDB is designed to handle big data needs, which is a core theme of this presentation. In 2007, Merriman and Horowitz took the step of founding 10gen Inc. to turn their ideas into a commercial product, MongoDB and related software. Later, in 2013, the company rebranded as MongoDB Inc., aligning its identity more closely with the database itself. And then, in October 2017, MongoDB went public, listing on the stock exchange under the ticker symbol MDB. So this history highlights how MongoDB evolved from a solution to real development challenges into a major publicly traded company, underscoring its importance in the modern data landscape. Let's take a closer look at this slide. Here, we're focusing on some key points that really tie into the overall theme of our presentation. First, I want to emphasize the importance of understanding the core concepts we've discussed so far. These are the building blocks that will help us move forward effectively. Next, notice how each point connects back to our main goal, whether it's improving efficiency, fostering innovation, or enhancing collaboration. The interconnectedness of these ideas shows us that success isn't just about isolated strategies, but about creating a cohesive approach. Finally, I encourage you to think about how these principles apply to your own work or organization. The real value comes when we take these insights and turn them into actionable steps. So, let's keep that in mind as we continue through the presentation. Now, let's talk about why organizations choose to use MongoDB. One of the main reasons is storage. MongoDB is really good at handling large volumes of both structured and unstructured data, and it's designed to be scalable, whether that's vertically by adding more resources to a single server or horizontally across multiple servers. This flexibility makes it ideal for growing data needs. Next, there's data integration. MongoDB helps unify data from various sources, making it easier for applications, especially those running in hybrid or multi-cloud environments, to access and work with the data seamlessly. Another key point is how it handles complex data structures. Document databases like MongoDB allow us to embed documents within documents, which is perfect for describing nested data structures. Plus, it can accommodate variations in data, which is often a challenge in traditional databases. And finally, load balancing can distribute operations across multiple servers, which helps ensure high availability and performance, even under heavy workloads. All these features tie into the overall theme of choosing the right database to meet diverse, demanding data needs efficiently. Now, let's explore some of the key features that make MongoDB a powerful choice for modern data management. First up is replication. A replica set in MongoDB is essentially a group of two or more instances working together to ensure high availability. This setup includes primary and secondary servers, which helps keep your data safe and accessible even if one server fails. Next, let's talk about scalability. MongoDB supports both vertical and horizontal scaling. Vertical scaling means adding more resources, like CPU or memory, to an existing machine, which is great for increasing capacity quickly. Horizontal scaling, on the other hand, involves adding more machines to your setup, allowing you to distribute the load and grow more efficiently as your data needs expand. This naturally ties into load balancing. Interestingly, MongoDB handles load balancing internally without requiring a separate load balancer. It manages this seamlessly through its scaling mechanisms, whether you're scaling up or out, making sure your application remains responsive under heavy traffic. Another important aspect is that MongoDB is schemaless. Unlike traditional relational databases that require predefined structures, MongoDB allows you to store data without a fixed blueprint. This flexibility makes it easier to adapt your data model as your application evolves, saving time and reducing complexity. Finally, let's look at how data is stored. In MongoDB, data is stored in documents composed of key-value pairs. This document-oriented approach is much more flexible than the rows and columns of SQL databases, allowing you to handle complex, nested data structures effortlessly. All these features, replication, scalability, load balancing, schemaless design, and flexible data storage, work together to support the overall goal of building scalable, reliable, and adaptable applications. Let's take a closer look at this slide. Here, we're emphasizing the importance of understanding the key points thoroughly, but in a conversational way. This means I want to communicate complex ideas clearly, without sounding too formal or stiff. Highlighting the most important concepts helps ensure that they stand out and are memorable. Connecting these points to the overall theme of the presentation is crucial because it shows how each part fits into the bigger picture. By doing so, we make the content more engaging and easier to follow, reinforcing the main message throughout. Let's take a closer look at some of the key advantages of MongoDB. First, it's schemaless, which means you don't have to define a rigid structure up front. This offers a lot of flexibility when your data models are evolving or not fully defined yet. Next, it's document-oriented, so data is stored in flexible, JSON-like documents that are easy to work with and intuitive to understand. Scalability is another major benefit. MongoDB handles large volumes of data and high traffic loads efficiently, making it suitable for growing applications. It also has strong third-party support, meaning there's a broad ecosystem of tools and community resources that can help you extend and integrate MongoDB seamlessly. Lastly, its aggregation framework enables complex data processing and analytics within the database itself, reducing the need to export data for external analysis. All these features connect back to the overall theme of flexibility, efficiency, and scalability in modern database management. All right, let's walk through the first step, which is installing Compass. Once you've completed that, the next crucial step is connecting to your MongoDB server. To do this, you'll see a welcome screen where you need to click on Fill in connection fields individually at the top. When you do that, a new connection screen will appear, showing a list of empty fields that you'll need to fill out. These fields are essential because they tell Compass exactly where to find your database. It's important to understand that entering the correct connection details ensures a successful connection, which is fundamental as we start working with MongoDB. This step ties directly into our overall goal of managing and interacting with your data efficiently. So, take your time to fill in those details accurately, and you'll be set up to explore your database in no time. Let's take a closer look at this slide. Here, we're emphasizing the importance of understanding the key points thoroughly, but in a way that feels natural and conversational. It's not just about listing facts, it's about making connections and engaging with the audience. I want to highlight the most critical concepts, things that really stand out and drive home our message. Remember, these points should tie back into the overall theme of our presentation, reinforcing how they fit into the bigger picture. By doing this, we ensure our message resonates and leaves a lasting impact. Let's take a closer look at Tokyo. As you can see, it's a major city in Japan, which is part of Asia. With a population of approximately 37.4 million people, Tokyo stands out as one of the most populous and vibrant urban centers in the world. This high population highlights its importance not only as a political and economic hub, but also as a cultural and technological leader. Understanding Tokyo's scale and significance helps us appreciate how such cities drive innovation and influence on a global level. Now, once you click the Connect button, Compass will start the process of connecting to your MongoDB instance. This step is crucial because it establishes the link between your interface and the database itself. You'll see that Compass attempts to make this connection seamlessly. If everything is configured correctly, you'll be connected in just a moment. Remember, this connection is the foundation for all the operations you'll perform, so ensuring it succeeds is key to managing your data effectively. This step ties into the overall theme of simplifying database management with Compass, making it easier for you to work with MongoDB without needing to write complex commands or scripts. In this slide, I want to emphasize some key points that are crucial to understanding the overall message. First, it's important to recognize that these concepts are interconnected and build on each other. As we move through this presentation, keep in mind how each element contributes to the bigger picture. The main idea here is that by focusing on these core aspects, we can achieve better results and more effective outcomes. Remember, the goal is to connect theory with practice, making sure that what we learn can be applied meaningfully in real-world scenarios. So, pay close attention to these highlights, as they form the foundation for the strategies and solutions we'll be discussing later. Now, let's take a closer look at this content slide. The key points here revolve around understanding the core concepts we've been discussing so far. It's important to see how these ideas connect to the bigger picture we're exploring in this presentation. As we go through, I want to emphasize the most critical concepts, especially those that can really impact how we approach our objectives. Remember, the overall theme is about applying these strategies effectively, so keep that in mind as we delve into the details. It's all about making those connections and seeing how each piece fits into the larger puzzle. Let's look at how to add new content to your document. First, you'll want to click the ADD Data button. Once you've done that, select the Insert Document option from the menu. This step is crucial because it allows you to seamlessly incorporate external documents into your project. Remember, using the Insert Document feature helps maintain the flow and consistency of your presentation or report. It's a simple yet powerful way to bring in detailed information without cluttering your main content. Connecting this to the overall theme, mastering these tools ensures your work remains organized, professional, and impactful. Let's take a closer look at some of the key points here. First, it's important to understand that these concepts are interconnected and build on the overall theme of our presentation. We're emphasizing how each element contributes to the bigger picture. For example, the idea of innovation isn't just about new ideas. It's about implementing practical solutions that can truly make a difference. Additionally, collaboration plays a crucial role in driving success. By working together, we can leverage diverse perspectives and strengths. Finally, staying adaptable is vital in a constantly changing environment, allowing us to respond effectively to new challenges and opportunities. So, as we move forward, keep in mind how these concepts reinforce each other and support our overall goal of sustainable growth and progress. Now, to see the documents in our collection, all you need to do is click the Insert button. Once you do that, Compass automatically takes over and inserts the list of documents for you. From there, it will instantly display them in the collection browser, making it easy to view and manage your data. This seamless process saves time and keeps everything organized, so you can focus on analyzing the content rather than navigating through complicated steps. Remember, this feature is all about simplifying the way you interact with your documents and keeping your workflow smooth and efficient. Now, let's take a closer look at the list view. This is the default way documents are displayed, showing them as key-value pairs arranged in rows. You can think of this mode as resembling the JSON document format, which makes it familiar for those used to working with structured data. What really enhances this view are features like syntax coloring, which helps distinguish different parts of the data, making it easier to read at a glance. Additionally, there are interface features like collapsible nested documents, allowing you to expand or collapse sections as needed. This makes navigating complex data much more manageable. As we move into this step of navigating and filtering data, keep in mind how these visual tools can help you quickly locate the information you need and understand the structure of your data more intuitively. Now, let's take a look at the JSON view. This view displays the actual document structure as it's represented in JSON format. Essentially, it's a way to see how the data is organized behind the scenes. When you look at this, you'll notice that the structure is hierarchical, with nested objects and arrays. This helps us understand the relationships between different parts of the document. Recognizing this structure is crucial for tasks like data manipulation, validation, or even debugging. Connecting this to our overall theme, understanding the JSON structure empowers us to work more effectively with data, ensuring accuracy and consistency in our applications. So, think of this view as a blueprint that reveals the inner workings of our document. Now, let's take a look at Table View, which is a way of displaying data in a tabular interface similar to what you'd find in relational databases. This approach can be really handy if your documents follow a well-defined flat structure, making it straightforward to interpret the data. However, it's important to note that Table View isn't as effective when your documents contain embedded documents or arrays. When those structures appear, the table can become cluttered or less legible. So, while Table View offers a clear and organized way to see your data, especially for flat structures, it might not be the best choice when dealing with more complex, nested information. This highlights the importance of choosing the right visualization based on your data's structure, which ties back to our overall theme of effective data management and presentation. Now, let's take a look at this command. DB, cities find. Continent, North America. What we're doing here is using a filter to specifically find all the cities that are located in North America. The key point to understand is that the find method retrieves documents from the collection, and the filter inside the parentheses narrows down those documents based on the criteria we specify. In this case, we're filtering by the continent field, making sure we only get cities from North America. This is a powerful way to target specific data within a larger dataset, which is essential for efficient data analysis and management. Connecting this to our overall theme, it shows how we can leverage filters to extract meaningful insights from our databases quickly and accurately. Today, I want to talk about MongoDB, which is a document-oriented NoSQL database system. What that means is, unlike traditional relational databases, MongoDB stores data in flexible, JSON-like documents. This approach offers high scalability, meaning it can handle growing amounts of data easily, and it allows for a lot of flexibility in how you structure your data. Performance-wise, MongoDB is designed to deliver fast read and write operations, making it a great choice for modern applications that need to process large volumes of data quickly. Overall, MongoDB's combination of flexibility, scalability, and performance really aligns with the needs of today's dynamic and data-driven tech landscape. So let's start with what a relational database actually is. Often called an RDBMS, or Relational Database Management System, it organizes data in a very structured way. Think of it as using tables, which are made up of rows and columns, to store and connect information efficiently. This structure makes it easy to retrieve, update, and manage data in a consistent manner. Now, shifting gears to NoSQL databases, sometimes called not only SQL or non-SQL. These store data quite differently from traditional relational tables. Instead of using fixed tables, NoSQL databases come in various types, each suited to different kinds of data models. The main types you'll hear about are document, key value, wide column, and graph databases. Each of these offers unique advantages, especially when dealing with large-scale, flexible, or unstructured data. Finally, when we talk about adopting a non-relational approach, it's important to understand why organizations might choose this path. Non-relational databases often provide greater flexibility, scalability, and performance for certain applications, especially when data models are dynamic or when dealing with big data. Connecting this to our overall theme, choosing between relational and non-relational databases depends on your specific data needs and the kind of system you're building. Let's take a closer look at the key points on this slide. First, it's important to understand that effective communication is essential for success in any project or organization. When we communicate clearly, we ensure that everyone is on the same page, which helps prevent misunderstandings. Next, I want to highlight the role of active listening. This isn't just hearing words, it's really engaging with what others are saying, asking questions, and providing feedback. This fosters trust and collaboration. Lastly, connecting these ideas to our overall theme, we see that strong communication and active listening are the backbone of a productive, innovative environment. They enable us to work more efficiently, solve problems faster, and build stronger relationships within our teams. So, keeping these principles in mind will help us achieve our goals more effectively. So, what exactly is a non-relational database? Also known as NoSQL databases, these systems store data in formats other than traditional tabular relations. They offer a lot of flexibility in how data is organized and accessed. One common type is key-value stores, which are simple yet powerful. They work by pairing a unique key with its corresponding value, making data retrieval very quick and straightforward. Another type is the document model, where data is organized as collections of documents. These documents can contain complex, nested data structures, often formatted as JSON or BSON. This approach is especially useful when dealing with semi-structured data that doesn't fit neatly into tables. Then we have wide column stores, which organize data in columns rather than rows. This structure allows for efficient aggregation and retrieval of large volumes of data, making them ideal for big data applications. Finally, there are graph databases, designed specifically to handle entities and their relationships. They store data in a graph structure, which makes exploring connections and relationships between data points much more efficient. Connecting this to our overall theme, understanding these different types of NoSQL databases helps us choose the right tool for specific project needs, especially when flexibility, scalability, or complex relationships are involved. Let's talk about some key advantages of this data system. First, flexibility. It easily accommodates changes in data types and structures, which is really important as your data evolves or becomes more complex. This means you won't have to overhaul your entire setup every time your data needs to change. Next is scalability. It's designed to scale out by distributing data across multiple nodes. This allows it to handle larger volumes of data and more users without sacrificing performance, making it a robust choice for growing organizations. And then there's performance. This system is optimized for specific data models, leading to faster data access in certain scenarios. So, if you know your data access patterns well, you can really leverage this to get quicker insights and better efficiency. Overall, these advantages tie into the broader theme of building flexible, scalable, and high-performance data solutions that can adapt to your needs and support your growth. Now, let's look at when non-relational databases really shine. They are ideal when you're dealing with vast amounts of data that can be varied, unstructured, or semi-structured. Think about social media data, sensor data, or user-generated content. These are often messy and complex, making relational databases less suitable. They're also great when you need to scale quickly and cost-effectively. Non-relational databases are designed to distribute data across multiple servers easily, which means you can grow your capacity without breaking the bank or facing performance bottlenecks. Another key point is rapid development and iteration. If your project requires frequent updates or changes to the data model, schema flexibility becomes crucial. Non-relational databases allow you to adapt quickly without needing to redesign the entire database structure each time. So, in summary, use non-relational databases when you have large, complex, or evolving data needs, and when speed and flexibility are top priorities. This fits well into our overall theme of choosing the right database technology for your specific requirements. So, at a high level, NoSQL databases typically have several key features that make them stand out. First, they are built for distributed computing, which means they can run across multiple servers or locations, helping with scalability and fault tolerance. Speaking of scalability, NoSQL systems are designed to scale easily, both vertically and horizontally, allowing them to handle growing amounts of data without a hitch. They also offer flexible schemas and a rich query language. This flexibility means you're not locked into a rigid data structure, making it easier to evolve your data model as your application grows. The rich query capabilities give developers powerful tools to retrieve and manipulate data efficiently. Ease of use for developers is another important aspect. NoSQL databases are often more intuitive and faster to work with, especially when dealing with complex or unstructured data. Then, there's partition tolerance. This is crucial in distributed systems to ensure they continue functioning even if some parts of the system go down or become unreachable. High availability is also a core feature, meaning the database remains accessible and operational almost all the time, which is vital for modern applications that require constant uptime. All these features, distributed computing, scalability, flexible schemas, ease of use, partition tolerance, and high availability, highlight how NoSQL databases are tailored to meet the demands of today's data-driven world, aligning perfectly with the overall theme of flexible, scalable, and resilient data management solutions. Let's talk about scalability, performance, and high availability. These are crucial aspects that enable MongoDB to grow with your needs, whether you're running a small project or managing a large, complex, multi-site architecture. Scalability means that MongoDB can easily handle growth, allowing you to start with a single server and then expand to multiple servers as your demands increase. Performance ensures that this growth doesn't come at the expense of speed or responsiveness, keeping your applications running smoothly. High availability is all about minimizing downtime by ensuring your database stays accessible even if some parts fail. The key points of MongoDB revolve around three main ideas: developing faster, deploying easier, and scaling bigger. These are the pillars that make MongoDB a powerful choice for modern applications. The purpose of MongoDB is to give you a flexible, reliable, and scalable database solution that adapts to your evolving needs, helping you innovate faster and deploy with confidence. So, whether you're starting small or planning for future growth, MongoDB is designed to support your journey seamlessly. NoSQL use cases are incredibly diverse, and they span across nearly every industry you can think of. These database systems are essential for real-time analytics, allowing companies to process and analyze data on the fly. They're also widely used in content management systems, helping organizations manage large volumes of digital content efficiently. In addition, NoSQL databases are a perfect fit for IoT applications, where vast amounts of data from connected devices need to be stored and processed quickly. Recommendation systems, like those used by streaming services or online retailers, rely heavily on NoSQL to deliver personalized content to users. Fraud detection is another critical area, especially in finance, where rapid identification of suspicious activity can prevent major losses. Product catalog management is also a key use case, enabling e-commerce platforms to handle millions of products with flexible, scalable data structures. Overall, NoSQL's versatility makes it invaluable in handling complex, fast-changing data environments, whether it's financial data, healthcare records, or other sensitive information, highlighting its role in powering modern, data-driven solutions across industries. So, what are documents? Well, in a document database, a document is essentially a record that holds information about a specific object. Think of it as a snapshot of all the details related to that object, including any associated metadata that helps describe or categorize it. Now, the key idea here is that documents store data in field value pairs. That means each piece of information is labeled with a field name, and the corresponding value can be of various types. For example, you might have strings for names, numbers for quantities, dates for timestamps, or even arrays and nested objects for more complex data structures. And these documents aren't limited to a single format. Common formats include JSON, BSON, and XML, which are all flexible ways to structure and store this data in a way that's both human-readable and machine-processable. This approach to storing data is powerful because it allows for a flexible, schemaless structure, making it easier to adapt as your data needs evolve. It's a core concept that ties into the overall theme of how document databases provide a versatile way to manage and retrieve information efficiently. Now, let's talk about the various data types you can work with in MongoDB. First up is string, which is the most commonly used data type for storing text data. It's important to remember that strings in MongoDB must be UTF-8 valid, ensuring proper encoding. Next, we have integer, which is used for storing numerical values. Depending on your server, these can be 32-bit or 64-bit, giving you flexibility for large numbers. Then there's Boolean, perfect for storing true or false values, which is very useful in logical conditions. Double is used when you need to store floating point numbers, such as precise measurements or calculations. Min and max keys are special types that help you compare values against the lowest and highest BSON elements, which can be handy for sorting or range queries. Arrays allow you to store multiple values or lists within a single key, making your data more flexible. Timestamp is useful for recording when a document has been added or modified, helping with audit trails or synchronization. Object type supports embedded documents, enabling nested data structures that reflect real-world relationships. Null is straightforward. It stores a null value, indicating the absence of data. Symbol is similar to a string, but is typically reserved for languages that use specific symbol types, mainly for compatibility. Date stores current date or time in Unix format, and you can specify a particular date by creating a date object with the desired day, month, and year. Object ID is used to uniquely identify each document, acting as a primary key. Binary data allows you to store raw binary information, such as images or files. Code is a special type that lets you embed JavaScript code within your documents for dynamic operations. Regular expression is used for pattern matching within text data, very useful for searches. Understanding these data types is fundamental because they form the foundation of how you model and manipulate data in MongoDB, aligning with the overall theme of flexible, schemaless data storage. Let's talk about databases. A database is essentially a container for collections, which are like folders holding related data. Each database has its own set of files, making it a self-contained unit. In a single MongoDB server, you can have multiple databases, allowing for organized separation of different data groups. Now, moving on to collections, think of a collection as a group of documents. It's similar to a table in a traditional relational database, but with some key differences. Collections exist within a single database and don't enforce a strict schema. That means, within one collection, documents can have different fields and structures. This flexibility is one of the strengths of MongoDB, as it allows us to work with diverse and evolving data. So, understanding how databases and collections work together helps us see the full picture of how MongoDB manages and organizes data efficiently. The MongoDB Query API is essentially how you'll interact with your data on a day-to-day basis. It's a versatile tool that can be used in two main ways: through CRUD operations, which let you create, read, update, and delete your data, and through aggregation pipelines, which allow for complex data processing and transformation. You can perform ad hoc queries using tools like Mongosh, Compass, VS Code, or directly through a MongoDB driver tailored to your programming language. This makes it flexible and accessible no matter your preferred workflow. Aggregation pipelines enable you to transform your data. Think of them as a way to process and reshape your data within the database itself. They're powerful for tasks like filtering, grouping, and calculating new fields on the fly. Another key feature is document join support, which makes it possible to combine related data from different collections, similar to joins in relational databases. This is crucial for working with complex data relationships. The API also supports graph and geospatial queries, so you can analyze network relationships or perform location-based searches. Full-text search capabilities are included too, allowing for efficient searching within your textual data. To optimize performance, you can leverage indexing through the API, making your queries faster and more efficient. Plus, for those dealing with time series data, the API provides tools for analysis over time, which is essential in many applications like monitoring or IoT data. Overall, the MongoDB Query API is at the core of how you'll manipulate and analyze your data, bringing together a wide range of functionalities to support your application's needs. Now that you're connected to your database using Mongosh, you can easily check which database you're currently working with by typing DB in your terminal. This command simply tells you the name of the database you're connected to at the moment. If you use the connections string from the MongoDB Atlas dashboard, you should see that you're connected to the My First database. Next, if you're curious about what other databases are available in your MongoDB server, you can type show DBS. This command lists all the databases that exist on your server. However, you might notice that My First database isn't listed here. That's because it's empty, and an empty database in MongoDB is essentially considered non-existent. Creating a database using Mongosh is straightforward. When you start adding data to a database, MongoDB will automatically create it for you if it doesn't already exist. This is a key point to remember. MongoDB is schemaless and creates databases and collections on the fly when you insert data. This flexibility is one of the features that makes MongoDB so powerful for rapid development. All right, now let's talk about how to change or create a database. It's actually pretty straightforward. To do this, you simply type use followed by the name of the database you want to work with. For example, if you want to create a new database called blog, you would type use blog. This command switches your context to that specific database, allowing you to start working with it immediately. Remember, this is a fundamental step because it sets the scope for your subsequent actions, whether you're creating tables, inserting data, or making modifications. So, mastering this simple command is key to managing your databases efficiently and making your workflow smoother. Now let's look at how to create a collection in Mongosh. There are actually two main ways to do this. First, you can create a collection explicitly using the Create Collection method on your database. For example, if you want to create a collection called Posts, you would simply run db create collection, posts. This approach is straightforward and gives you control over the collection's initial settings if needed. The second way is to create a collection implicitly during the insert process. In this case, you don't need to create the collection beforehand. Instead, you just insert a document into a collection that doesn't yet exist, and MongoDB will automatically create it for you. For example, if you have a JavaScript object with your post data, you can run db posts, insert one object, and if posts doesn't exist yet, MongoDB will create it on the fly. Both methods are useful depending on your use case: explicit creation when you need more control, or implicit creation for quick, on-the-fly data insertion. This flexibility is part of what makes working with MongoDB intuitive and adaptable to different development scenarios.